My name is Christopher McClellan.
And I'm Glenn Hunt.
Today, we will be discussing the Icarus cognitive architecture and its use in multi-agent negotiations.
We'll begin by outlining the problem and its importance. We'll give a brief overview of Icarus, sketch our solution to the problem, and show some footage from an actual implementation.
Negotiation is an interaction between two or more agents who wish to reach an agreement or resolve a difference. By the end of negotiations, each agent wants to acquire some benefit for themselves.
Negotiation is an inherently complex behavior, well beyond the ability of animals like dogs and cats. Negotiations have played a major role in trade, politics, and personal lives. By studying negotiation, we seek to gain a deeper understanding of the nature of intelligence.
The minds of our agents are simulated using the Icarus cognitive architecture. The foundation and underlying architecture provides support for building towers and skyscrapers. Similarly, cognitive architectures provide the necessary structure for the development of the mind of an intelligent agent. This is accomplished by making theoretical commitments about the structures and processes underlying intelligent behavior. These commitments are use of short and long-term memories, representation and organization of elements in these memories, and processes which operate over elements in these memories.
Memory in Icarus is divided into short and long-term memories. Short-term memory consists of percepts, beliefs, and problems, and long-term memory consists of concepts and skills. Concepts and skills in Icarus are organized hierarchically. This means concepts may refer to percepts or other concepts. Skills refer to primitive actions in the environment or other skills. The processes which operate over these concepts and skills are inference, skill execution, and problem solving.
Percepts are information about the world the agent receives from its environment via sensors. These percepts are matched against hierarchical concepts in long-term memory using pattern matching techniques. Finally, deductive inference is applied over matched concepts forming beliefs about the agent's environment. In this example, the agent perceives that ball 01 is 0.5 units away. This matches against the concepts ball and near. Following deductive inference, the agent believes that ball 01 is a ball and that it is near.
Given a skill to execute, Icarus matches the name of the skill with the current belief state to select an applicable skill. A complex skill is any skill which has one or more subskills associated with it. A primitive skill, on the other hand, does not have any subskills. Instead, it executes some action of the environment. In this example, go-to-ball has been selected for execution. Because it matches the current belief state, the skill definition is retrieved from long-term memory. Go-to-ball has a single subskill, move. Icarus matches the name of this subskill with the current belief state, finds an applicable skill, and executes it. Because this skill is primitive, this causes the agent to move to the ball, completing execution of the original complex skill. For this scenario, we have a number of different agents that interact with each other. Namely, we have three types of agents: innocents, collectors, and capitalists. The world also contains a number of objects, including a chair, balls, and dolls.
The innocents are children who roam the world, traveling from ball to ball. As they roam around, they look for abandoned dolls, which they quickly pick up.
The collector is an adult who waits near a chair. He collects dolls and is willing to pay a reasonable price to agents who wish to sell him dolls. When he purchases a doll, he puts it in his safe, which causes it to vanish from the world. When this happens, a new doll randomly appears somewhere in the environment.
The capitalist is a child who desires money. He acquires cash by purchasing dolls from innocents at a low price and then selling them to the collector at a higher price.
When there's an innocent with a doll nearby, the capitalist goes to the nearest ball to intercept the innocent so that he can offer to buy his doll.
Once an offer is made, negotiations begin. Agents negotiate by speaking to each other about offers. Each utterance becomes a percept for the agent, which the agent uses to interpret and reason about the offer.
Once we put all these pieces together, we have a world in which multiple agents interact and regularly negotiate with each other.
This footage showcases Twig, the environment we're using to simulate negotiation. Each agent in the environment is running a separate instance of Icarus, which it uses to reason about and interact with the world. Agent behavior is initiated when the user executes a high-level skill.
In this example, each agent is running in a skill execution loop where a high-level skill selects subskills that match the agent's environment. As you can see, the capitalist has approached the collector with a doll he would like to sell.
When the collector notices that the capitalist has made an offer, he executes the appropriate skill to respond to that offer. Initially, the capitalist's offer is not very good. This matches the decline offer skill for the collector.
The capitalist notices that his offer has been rejected and makes a revised offer accordingly. This process continues until the collector accepts the offer, ending negotiation.
Although the current implementation is capable of handling basic negotiation, we believe more complex behavior is achievable. This version we've described does not take advantage of the problem-solving capabilities of the Icarus cognitive architecture, which would enable interesting and novel behavior.
All of the software we've used is free and available on the web. If you're interested in artificial intelligence, we encourage you to visit the following sites. Thanks for watching.